Hello everyone. In today's lesson, we are going to look at mathematical induction. So we are going to define mathematical induction as a method of proof that the mathematical formula is valid for certain positive integral values of n. Okay? So we are going to say it involves basically 4 steps, that is TAPE. Step number 1, we are going to test if the formula is true for the initial value of n, probably a 1, and then we go on to other values. Okay, so step number 2, we are going to assume that the statement is true for some arbitrary value, for example n is equal to k. Then step number 3, we are going to prove that if the statement is true for n is equal to k, comma, then it must also be true for n is equal to k plus 1. Then finally, we are going to conclude. I repeat, step number 1, we are going to test if the formula is true for the initial value of n, comma, then step number 2, we are going to assume that the statement is true for some arbitrary value of n is equal to k. Step number 3, we are going to prove that if the statement is true for n is equal to k, then it must also be true for n is equal to k plus 1. And then finally, we are going to conclude. Let's give it a try. Prove by induction that 1 plus 2 plus 3 plus dot dot plus n is always equal to n open brackets, n plus 1 close brackets, everything divided by a 2. So we say that we are going to go through 4 steps, and the step number 1 is for testing. Okay, so we are going to say test for n is equal to 1, and on the left hand side the first value is a 1. Okay, so we are going to say left hand side is equal to a 1. Now on the right hand side, we are going to get this value of n is equal to 1. We substitute it where we see n in our formula, and when we do it, we are going to have a 1 into, we substitute a 1 there, so that is a 1 plus a 1, everything divided by a 2. But inside the bracket, we have 1 plus 1, that is a 2. 2 times 1, that is a 2. Then divided by a 2. So by 2, 1 by 2, 1. Therefore, the right hand side is equal to a 1. But left hand side and right hand side, everything is equal to 1. What does that mean? The formula is valid for n is equal to 1. That is step number 1. Then step number 2, we are going to assume. So we are going to say, assume that the formula is valid for n is equal to k. So I'm going to get this value of n is equal to k. I substitute where I see n into our formula. So that is a 1, then plus a 2, then plus a 3, plus dot dot dot. The next value is a k. So and everything is equal to, we are going to get this k, we substitute into right hand side of the equation. So this is a k into a k plus 1, then everything divided by a 2. Now we said that step number 3 is to prove that if the formula is true or valid for n is equal to k, comma, then it must be true for n is equal to a k plus a 1. What does that mean? Where I see a k plus 1, where I see n, I'm going to substitute a k plus 1 into my formula. So I'm going to say 1 plus a 2, then plus a 3, then plus dot dot dot, then plus the last term here is a k, but now when I see n, I'm going to substitute a k plus a 1 and everything is equal to, I substitute a k plus 1 on the right hand side, so that is a k plus 1 into k plus 1, then plus a 1, everything divided by a 2, okay? But when I look on the left hand side, this expression is given as a k into k plus a 1, everything divided by a 2. So I'm going to just substitute a k into a k plus 1, everything divided by 2, then plus a k plus 1, everything is equal to a k plus 1 into k, 1 plus 1, that is a 2, everything divided by a 2. So I want to combine these terms into a single fraction. And how are we going to do it? I'm going to divide up and down by 2. And when I do it, I'm going to have a 2 by 2, that is a 1. 1 times the numerator, so we get k into a k plus 1, then plus a 2 into a k plus a 1. But we realize that a k plus 1 and a k plus 1 is common. So I'm going to factor it out. And when I do it, here I'm going to be left with a k, then a plus. When I factor out a k plus 1, here I'm going to have a 2, everything divided by a 2. Remember, this is our left hand side. But when we compare the left hand side in its simplest form to the right hand side, everything is equal. So since this is true, I'm going to conclude that the formula is valid for all integral positive values of n.